Hello everyone, my name is Abhishek and welcome back to my channel. So today is day 23 of our complete DevOps course, and in this class I'll introduce you to the world of containers. So before we jump onto the topic for today, I would like to make an announcement that the other day I created a Telegram group for our channel, and I will use this Telegram group to share some important resources, the resources that I come across while reading some content, or while I surf through the Medium blogs or any other resources. So it will be very handy for me to share the resources on the Telegram group instead on the YouTube community post where the information gets ignored, or after some time it is very difficult to scroll back and look into the resources that I shared. So if you haven't subscribed to the Telegram channel, please use the link in the description to join the Telegram channel and use the resources that I'm going to share. Okay, now coming to the topic for today, that is containers. So what we'll do today is we will try to understand the basics or introduction of containers. This is very important because before you jump onto the uh, concepts like creating projects with containers, or how one container interacts with the other container, all of these things, it is very important for you to understand the basics of containers. Afterwards, I'll also try to explain you what is Docker. So even if you are very new to DevOps, you must have at least heard this term called as Docker because it is very popular. So we'll try to understand what is Docker, but not today. We'll not create any projects or we'll not look into the Docker commands. This is just an introduction class. I want everybody to have their basics strong before we jump onto the creating projects and all other things. Then I'll also introduce you to Buildah, because in this DevOps course, I'm also going to explain you how to build projects using Buildah, because Buildah is a tool that you have to watch for. Going ahead, you will see more and more people asking you if you know Buildah, and people creating some complex projects with Buildah. So it is very important for you to understand Buildah as well, because it has a very good integrations with the modern day tools like Scopio and Podman. So okay, not today. We'll not do any projects, but we'll understand the basics of it as well. Now, before we jump onto this, what you need to understand is a virtual machine. So if you haven't watched the day 3 on our complete DevOps or DevOps Zero to Hero course, I'll definitely recommend to watch day 3 before you jump onto today's topic, because before understanding the world of containers, it is very important to understand the world of virtual machines. Because if you consider virtual machines as advancement to physical servers, then containers is an advancement to virtual machines. So definitely you should have understanding of virtual machines. So watch day 3 before you watch this video. But as an overview, like let's say you have a physical server, you purchase this physical server from IBM or HP, or it can even be your laptop, right? Your laptop is also a physical server. So most of the times when you use this physical server, you don't use the resources completely, right? So that was the problem. Even if you're using your laptop, you don't use the complete resources of your laptop. So to avoid this problem, okay, by resources, CPU, RAM, and hardware, all of these things. So if it is one personal laptop, then that is fine. But when you're dealing with the organization, you have thousands of servers and you are paying for all of these resources. So that was one of the major challenge. So to solve this problem, a new concept, or there was an advancement in the technology, and there was the inception of hypervisor. Hypervisor uses a concept called as virtualization. Okay. Now, what is virtualization? As the name suggests, virtualization is basically used to create a lot of virtual machines or virtual servers on top of your physical servers. So virtual server is basically a logical separation, right? A physical server is something that you can see, something that you have bought, but virtual machine is a logical isolation, or it's a virtual isolation where you have operating system for each of these virtual machines. Okay. And on top of this operating system, you would run your applications. So instead of one physical server, instead of running one application, what you are going to do is you are going to run multiple applications, and each of this application is run on a VM which has its own virtual operating system. Or I mean, it has an operating system, but this entire thing together is called as a virtual machine, because it's a virtual isolation that is created by your virtualization platform and hypervisor, right? So because each of these applications have their own operating system, so they are very secure. Even though these applications are running on a same physical server, but they are logically very tightly separated, not tightly coupled, they are tightly separated because of the individual operating system that they have. right? So this is the concept of virtual machine and how you can effectively use your physical server or your resources in the organization. Now this is very good, right? Now why we have to move towards containerization? If virtualization is working very well, why should we move towards containers? So this is a question, and this is how you will understand containers. Okay, so let's again try to understand here that let's say you have a physical server, and on top of this physical server you have installed a hypervisor. Okay, it can be your laptop as well again. So on top of your laptop also you can install a hypervisor and you can create multiple virtual machines. So for the easy understanding, let's say that you bought this physical server of 100 GB RAM and 100 CPU. Okay, now what you have done is you thought that okay, all of this 100 GB and 100 CPU cannot be used by one team or one project or one application. So you will use a hypervisor and you will create, let's say, four virtual machines. Okay, VM1, VM2, VM3, and VM4. On top of which you install operating system for each of this virtual machine. It can be the same thing that you do with EC2 instances, right? What AWS does is they buy physical servers from one of these vendors, or they manufacture their own physical servers. And on top of these physical servers, what they typically do is they install Zen hypervisors, and using this Zen hypervisors, they will ask you to create EC2 instances, right? So whenever you are creating EC2 instance, it's the same process. You are basically using the virtualization platform of AWS and creating the virtual machines or EC2 instances, where you use, whenever you are creating, you define that what operating system you want and all of these things. Well, this is very good. And you created, let's say, 25 GB RAM for each of this virtual machine. But of late, your organization realized that you are not using the complete capacity of this virtual machine, right? So you have saved some money from moving to physical servers to virtual machines. But even after moving to virtual machines, you have realized that one of your virtual machine or all of your virtual machines are not using the resources to their fullest capacity. That means virtual machine one has application one, and this application one, on its best day, let's say that this application one receives the maximum threshold load, and even after that it was only using 10 GB RAM and some 6 CPU. That means it is using only less than half, or it is using, like, it is wasting 15 GB RAM and some 19 CPUs, even when this application is running on the full capacity. Okay, and when it is running on the less capacity, that means it is even using very less resources and it is wasting a lot of resources. Now you can probably say that okay, on full capacity it is using only 10 GB, so let me reduce it. But what happens when it is running on low capacity, or what happens when this application is not at all receiving the load? So in that time you are wasting more than this 15 GB and 19 CPU resources. So this was one of the major drawback of virtual machine. You can see the same scenario on your EC2 instances as well, right? So what happens is, as a DevOps engineer, you might have created many EC2 instances. You might be playing with Jenkins. You might be even the viewers of our channel. All these 22 days, we have created a lot of examples and everything we tried on EC2 instance. But was there a case? Okay, so this is a question that I'm asking you. Was there a case when you have seen that your EC2 instance was running out of memory? How many times? So if it is running out of memory, how many times did you see this error? Very less, right? So you must have seen, I think most of the people must have not seen this error, that your EC2 instance is running out of resources. Even if it is running out of resources, you must have seen it very less number of times. That means most of the times you are using this EC2 instance with not I mean with very less resources, and you are wasting a lot of resources. This is a free instance, so you don't have a problem. But what if an organization that is using some 1 million EC2 instances? Okay, so let's say an organization is using 1 million EC2 instances, and they are seeing that all of these 1 million instances, or most of the 1 million instances, are wasting resources. So it is heavy loss for the organization. So to solve this problem, containers, or the inception of containers, taken place, right? So containers will solve the same problem. That is, they will effectively use your virtual machines to even reduce this problem. So the problem with physical servers was solved to some extent using virtual machines. Now to the problem of virtual machines is also solved to some extent with containers. Why I said to some extent? Because containers still have some drawbacks. uh, uh, you can use some advanced security policies, or you can do some more things, but even today virtual machines are very very secure when compared to containers, because I'll tell you the reason. But just to tell in one single line, virtual machines have a full operating system, so that means they have complete isolation, whereas with containers you will see that containers do not have a complete operating system and they do not run their full operating system. So that means there is a logical isolation, but the logical isolation is not complete. There is one or other way where you can talk from one container to another container, or each of these container talk to the host operating system to share some resources. So there are some drawbacks. So what we can say is virtual machines have solved some problems with physical servers, and containers have solved some problems with virtual machines. Okay, now let's deep dive and see what is the architecture of containers, because I've told you that okay, containers have solved some problems with virtual machines and all of these things. Let us see the architecture to understand it even in a better way, right? So containers can be created in two ways. One is you can create containers on top of virtual machines, and the other is you can create containers on top of physical servers as well. Okay, so let's say this is model one, where what a DevOps engineer will do is he will use the IBM or HP servers in his data center, in his organization data centers. What he'll do, he's install a operating system. On top of the operating system, he'll install Docker or any other containerization platform. To create containers, you will need a containerization platform. Just like to create virtual machines, you need a hypervisor or a virtualization platform. So you created a Docker platform or a containerization platform, and on top of this, you have created multiple containers. Okay, so this is one way of creating containers. And the other way is you can basically create a EC2 instance or a virtual machine, anything on top of a physical server. Okay, let's say this is a physical server. It can be your Amazon or cloud provider physical servers, or it can be physical server on your organization as well. Okay, so on top of this, you have created a virtual machine. On top of virtual machine, you can create Docker. Okay, so here you are directly creating on the physical servers, and here you are creating on top of the virtual machines. So Docker or containerization platforms do not really care if they are doing the containerization on top of physical servers or on top of virtual machines. And you will see more and more organization using the model 2. Why? Because when you are maintaining your own physical servers, there is a lot of maintenance overhead, right? So there has to be a dedicated team who maintains these physical servers. Whenever there are new patches, whenever there are new security fixes, or whatever is the case, you have to maintain your data center, right? So you need system administrators. Whereas if you are moving to AWS or any other cloud provider, or you're creating virtual machines on top of any physical servers, so your maintenance overhead is less unless you own that physical servers. So that's why these days you will see more and more of model 2. Initially people were using model 1 as well, but now the usage pattern has changed or shifted a lot to model 2, because these days everybody is on cloud provider, and these days people are looking to reduce the maintenance overhead. Organizations are not willing to maintain their own data centers. So to solve all of these problems, they are using model 2. So in model 2, you will have a physical server, but if you are using a cloud provider, you will not see this physical server. You will directly start from this step where you will create a EC2 instance, or where you will create a virtual machine on Azure platform. On top of it, you will create a containerization platform like Docker or any other containerization platform. And on top of it, you will start creating containers. Okay, so you might say that, okay, both of the diagrams looks very similar. What is the difference? Like I told you, the major difference is that containers are very lightweight in nature. Okay, why are they lightweight? First of all, let's try to understand that. Then let's move to the next thing. So the Docker containers, basically, as I told you, they do not have, okay, they do not have a complete operating system. If this is C1, C2, C3, C4, C5, so the Docker containers, on a contrary, virtual machines, if we see the previous example, a virtual machine has a complete operating system and they have a complete isolation and security. Whereas containers, what they do is they use the resources from the base operating system, or they use the resources from the virtual machine or physical server that they are running on. For example, if the virtual machine is using a Linux platform, and your container requires any dependencies, or it requires any uh, uh, any shared libraries or any of the things from the host operating system or the host virtual machine, they will share the resources. So all of them will try to use from the host operating system. So this is one of the major thing. So saying that, do I mean to say containers do not have operating system at all? No, they will have a minimal operating system, or they will have a base image. Okay, so a container is nothing but, a container is a package, or it's a bundle which is a combination of your application plus your application libraries, that means your application dependencies, plus system dependencies. Okay, your application might require some system dependencies. Let's say your application might require Python, or your application might require any system dependencies. So what your Docker container does is, it will be a package of your application libraries and system dependencies. Any other system related packages or any other shared libraries, okay, let's say your etc or your any other shared libraries, will be used from the host operating system. So that's why Docker containers are very lightweight in nature. So for example, you have a virtual machine. Okay, to take a backup of your virtual machine or to create an image of your virtual machine, what you will do is, for your virtual machine you will create a snapshot, right? So usually the snapshots are 2 GB, 3 GB, 1 GB, right? This will be the size of your snapshots. I'm taking a basic example. Okay, even if you consider a very minimal, so your snapshots might go to 1 GB with your application installed, all the dependencies installed and everything. Whereas with container, if you, it depends on the type of container again, but with container you might see this falling into MBs, like it can be 100 MB. Okay, if your application has a lot of dependencies, it might go up like 500 MB, or it depends on how you are using the base image. Are you using multi-stage Docker and all of the things? I'm not going into the details, but you need to understand that there is a significant drop in the size of your image. So because the size of the image or the containers are lightweight in nature, what happens is they are even easy to ship. What do I mean by ship? To move from one place to another. Let's say you want to deploy this Docker container onto a container platform, or you want to deploy this Docker image onto Kubernetes or anything. They're very easy to ship and they're very easy to transfer. Okay, so this is one more advantage. What I'm trying to convey here is Docker containers are very lightweight in nature. And if somebody asks you why are they lightweight in nature, because they do not have a complete operating system. Okay, you can say that Docker containers or containers do not have a full operating system, and they use the resources from the base operating system or the operating system on which they are running on. But your container, like let's say you have a virtual machine, and on top of this virtual machine you want to run some 10 containers, and one container requires Python, second container requires Node.js, third container requires Java. Let's say they are in different forms. So what you will do is, like I told you, in your Docker image you can use a base image, and this base image, like I told you, it can have all of the system dependencies. Okay, so this system dependencies along with your application plus application libraries will form your Docker container, or will form your Docker image. So that's why never say that Docker images or Docker containers do not have an operating system, but they will not have a complete or full operating system. They will have a very minimalistic OS, or they will have a very minimalistic system packages, system dependencies. So this is about your Docker containers or containers in general. So whenever I'm saying Docker containers, always understand that I'm talking about containers and the concept of containerization. The reason why I'm saying Docker containers, so that many people will be able to correlate, because always, most of the times when you are reading about containers, it is like equivalent to reading about Docker containers. Like I told you, in this specific course, we'll also cover Buildah, so that you will get to see a different perspective. All the time we talk about Docker, but now you will also see, using this course, the other way of creating images and deploying the containers. I hope the concept of containers is clear till now. Now, what what happens is, why Docker is very popular. So Docker was a containerization platform, and Docker helped the community to write the Docker images. Like Docker came up with improving this concept of containerization, and it created a lot of commands, like user interface and user experience with Docker. Using some Docker commands has become very simple. So to create a container, what Docker has done is it said that, okay, you don't have to worry a lot. All that you need to do is you can simply write a Docker file, right? Just like we write Jenkins files, or just like we write any other script files, you can simply write a Docker file and you can submit this to Docker platform, or you can submit this to Docker engine using some Docker command. Okay, I'll explain that commands, don't worry about it. And this Docker engine will convert this Docker file into an image. Okay, this is a Docker image or a container image. Now again, using some Docker commands, you can convert this image into container. Okay, so if somebody is asking you what is the life cycle of Docker or what is the life cycle of containers, what you will say is the first stage would be to write. Again, I'm only talking about Docker files for now. Let us ignore about Buildah for now. So the first stage would be to write a Docker file and to execute this Docker file and create a contain sorry and to create an image, and again execute this image and create a container. So if you're using Docker platform, what will happen is there is something called as Docker engine, okay, which will receive all of these inputs. So you want to convert from Docker file to Docker image to Docker container, you can submit your Docker commands to this Docker engine and it will create all of these things. Just for your reference, basically what we'll do is whenever we want to create a convert from Docker file to Docker image, you'll use a command called as docker build. And again, here to create a container out of image, you will use a command called as docker run or exec, like just consider docker run. Okay, so this way you can create Docker file to image and from image to container. This is a life cycle of Docker. So now said a lot of things. Now let us also try to see that, okay, now everything is looking good. What is the reason for new tools and new technologies? Don't worry about this next 5 minutes that I'm talking about. So if the things are going out of your head, or if things are going slightly complicated, don't worry about it right now, because anyways when we do the live projects you will understand more about these details. But because I also want to introduce you Buildah. So what is the problem here is that Docker is basically more very much dependent on something called as Docker engine. Okay, and this Docker engine is basically a single point of failure. What is SPOF? It's a single point of failure. Now let's say if a Docker engine is down for some reason, that means to say that all your Docker containers will stop working. This is a terrible way, right? So off late the organizations or off late the Docker community is working on this one. And the major drawback is that till now there is no, I mean, till now you cannot work around with this issue, that if your Docker engine is going down, then all of your containers will not be responding. And your customers, like let's say you are using Docker and your test team or your customers is looking away, but your containers are not working or not responding because your Docker engine is down. So to avoid this single point of failure and to solve various challenges, like what happens is whenever a Docker image is being built from Docker file, it creates a lot of layers. So again, as I told you, don't worry about this particular section right now. If you are not able to understand it, don't worry. While we do a lot of projects on Docker, you will understand. But it creates a lot of layers, and each of this layer again takes a lot of space, or a lot of storage on your disk. So to solve again this problem, instead of creating a lot of layers, you can and to solve the problem of a lot of layers, to solve the problem of single point of failures and other challenges, Buildah said that, okay, let me create a tool, and this tool will help you to solve this problem. So Buildah will aim to solve the layers problem, SPOF problem, simplicity. It works very well with Scopio and Podman. So that's why you should also learn Buildah. So it doesn't take a lot of time. Buildah basically works a lot on commands. So you don't have to write something like Docker files. So in Buildah, you can basically write a shell script. And in the shell script, you can put all of the Buildah commands and it would create a image for you. And this image can be a Docker image or any other OCI compliant image. So Buildah also supports Docker images. You can also create Docker images using Buildah. right? So this is basically about the introduction to containers. If something is not easy to understand, please let me know. Like I told you, provide me the timestamp and tell me that okay, at this point of time I'm not able to understand something, so that I can create a YouTube shorts video, or I can reply back to you in the comment section saying that okay, this is how it works and all of the things, or I can share some reference material. I hope you enjoy the video. If you like the video, click on the like button. If you have any questions, post that in the comment section. And don't forget to share this with your friends and your colleagues. I'll see you in the next video. Take care, everyone. Bye bye.